Hello everyone, I hope you're all doing well. My name is Neil and in today's video we're going to explore exponential equations. We'll start with some basic examples to ensure you understand the foundation, and then we'll gradually move on to more challenging questions. Let's get started. The first question is 10 to the power of 2x equals 1000. Before solving this, we know that when we have, for example, a to the power of m equals a to the power of n, when two exponential expressions with the same base are equal, their exponents must also be equal, which means m equals to n. But make sure that a is bigger than 0 and it's not 1. By knowing this, we are going to solve this one. You know that 1000 is 10 times 10 times 10, so you can rewrite this as 10 cubed or 10 to the power of 3, and we have 10 to the power of 2x. So according to this rule, a is 10 here, so the bases are equal, and we can equate the exponents, which means 2x equals to 3. Divide both sides by 2 to isolate x, and x is 2 halves or 1.5. This was the first one, which was really easy. And this is the second question. 7 to the power of x plus 2 equals 49 to the power of x. So you know that 49 equals 7 times 7, which is 7 squared raised to the power of x, and we have 7 to the power of x plus 2. According to power rule, when you have a power like n raised to another power like n, you are allowed to multiply these two exponents, a to the power of m times n. So we are allowed to multiply 2 by x. So we have 7 to the power of x plus 2 equals 7 to the power of 2x. So we know that the bases are the same, so we can equate the exponents, which are x plus 2 equals 2x. Subtract x from both sides, so x would be 2. So far so good. Let's jump into the third question. Okay, 25 to the power of 3x minus 2 equals 125 to the power of negative x plus 1 over 3. Okay, so we know that 25 equals 5 times 5, which is 5 squared, and 125 is 5 times 5 times 5, which gives you 5 cubed. So express 25 as 5 squared raised to the power 3x minus 2, and 125 expressed as 5 cubed raised to the power of negative x plus 1/3. And as I said before, we are allowed to multiply powers according to power rule. 5 to the power of, so you know that 2 should multiply by all terms, which gives you 6x minus 4. This is distributive law. 3 times negative x, negative 3x. 3 times 1/3 gives you positive 1. So since the bases are the same, we are allowed to equate the exponents. 6x minus 4 equals negative 3x plus 1. Okay, so you can add 3x to both sides. We will have 9x minus 4 equals 1, and then add to both sides. 9x equals 5. So x equals to 5 over 9. This is the answer of x. And this is another question. We have 3 lots of 27 to the power of x equals to 1 over 243. Okay, first of all, we can simplify the left-hand side. So we have 3 times 27 to the power of x equals 1 over 243 according to negative exponent rule. When we have a to the power of negative m, we can rewrite it as 1 over a to the power of m. So we can rewrite 1 over 243 as 243 to the power of negative 1. In fact, we should reciprocal the fraction, which gives you 243, and then the power of is 1, and you should change the sign, which gives you the opposite sign, negative 1. So far, so good. We are not allowed to multiply 3 by 27 to the power of x because there is no equal base or even exponents. So we can rewrite 27 as 3 cubed raised to the power x 243 to the power of negative 1. And we know that when we have two powers, we can multiply them. 3 times 3 to the power of 3x. And then, according to product rule, when we have a to the power x times a to the power of y, you can write the same base and add exponents, x plus y. So we have this rule here. Consider the power of 3 as 1. So 3 to the power of 3x plus 1 equals 243 to the power of negative 1. Okay, so now it's time for rewrite 243 as an exponential number with the base 3. You can use the factor tree. 243 is 3 times 81. 81 is 27 times 3, 9 times 3, and 3 times 3. We have 5 of 3 as prime factors. So you can rewrite 243 as 3 to the power of 5 raised to the power of negative 1. Okay, so 5 times negative 1 is negative 5. So far, so good. Because the bases are equal, we should equate the exponents. So 3x plus 1 equals negative 5. 3x is negative 6 and x is negative 2, which is the answer of this question. Okay, in part 2 of this video, I'm gonna solve more challenging exponential equations using logarithm. Okay, see you in next video. Bye-bye.